that the exhaust gases from your car during a journey are squashed into a bottle and weighed. Compared with the weight of petrol used, how much do you think the exhaust gases will weigh? Much lighter, about the same, or much heavier than the petrol? Pause the video till you've thought of your answer. Well, the answer is that they will be much heavier because you have added oxygen to the petrol, releasing carbon dioxide into the atmosphere. When we burn any fossil fuel, we always put extra carbon dioxide into the air because the fuels contain carbon, the principal element making up living things. So here's another question. Like all other animals, we breathe out carbon dioxide from the respiration of our food. But why does this carbon dioxide not add to the carbon dioxide in the atmosphere? Pause the video till you've thought of your answer. The answer is that this carbon dioxide is part of the natural carbon cycle. It came from your food, say bread, which got its carbon from the atmosphere when it was growing as a wheat plant. Let's see where the people of the world get their energy. 200 years ago, we got our energy from biofuels, traditional energy sources that are driven directly or indirectly by the daytime energy from the sun. Firewood, burning in air to heat our homes and cook our food. Grass and air for animals to respire, gaining energy to pull our ploughs and carriages. Our own food, which we joined with oxygen to give us energy to use our muscles. Nowadays, burning these fossil fuels with oxygen has freed half the world from being limited by solar energy. But there are still many people who live only with biofuels, wood for cooking and heating, and muscle power for farming and transport. We use fossil fuels about equally for generation of electricity, mostly coal, transport, mostly oil, and heating and industrial uses, mostly natural gas. To reduce our carbon dioxide emissions, we must burn fossil fuels more efficiently and try to replace them with alternatives. Efficiency. Filament light bulbs use 100 units of electricity to produce just 3 units of light. We should replace them either by fluorescent bulbs, which use only 6 units, or LEDs, which transform almost 100% of the electricity into light using only 3 units of electricity to produce the 3 units of light. Trains and trams can generate electricity as they brake instead of wasting the kinetic energy as heat when they stop. For motor vehicles, we can continue to improve the number of kilometers driven per litre, and we can drive more slowly and carefully with less use of the brakes. Our homes should be well insulated, especially the roof, so we waste less fuel in the winter. In hot countries, houses should be built so that they are naturally cool to save on air conditioning. Better still is to replace fossil fuels with alternatives. Many countries already use hydroelectricity, which is generated from falling water and therefore solar powered, and we are seeing wind turbines and solar panels beginning to make an impact on electricity supply. Research into energy from the tides and waves is producing useful results too. And there is nuclear energy. France generates 85% of its electricity this way, which does not release carbon dioxide, but we do have to consider the problem of safe disposal of nuclear waste. If we replace coal, which is almost pure carbon, by natural gas, which is methane, CH4, as a fuel for electricity generation, half the oxygen used will join with the hydrogen rather than carbon, so our emissions of carbon dioxide will be halved. This is the argument given for developing so-called fracking for natural gas, which would replace coal in power stations. And we can use our muscles more, walking and riding a bike for short journeys. So to summarize, in order to reduce the amount of carbon dioxide we release into the atmosphere, we need to reduce our reliance on fossil fuels by making our processes more efficient and by replacing the fossil fuel with alternative energy sources by generating electricity from the wind, waves, water, from the wind,